Cool. So, hello there. Let's rock and roll. So Stephen Johnson, in his book Where Good Ideas Come From, describes this idea from Stuart Kauffman called the adjacent possible. And here's a passage. Good ideas are not conjured out of thin air. They're built on a collection of existing parts, the composition of which expands and occasionally contracts over time. So, example, if we take some idea like Netflix, it's connected to all of these adjoining thoughts. So that might be on-demand video, cable, television, moving pictures, and just being able to capture an image at all. And so before you think that original thought, being able to capture an image at all, you can't think something adjoined to Netflix, like Netflix and chill. And we can do the same exercise with scrollable, tappable lists. So looking at my iOS podcast app experience in 2018, I recognized that as a scrollable list. And that list contains tappable elements, which are effectively buttons with sub-buttons. But before we were able to get to that visual language, we had to step through all of these adjacent possibilities of earlier iterations of buttons. And just regarding scrolling, there's a time where we had to make sure authors understood that just because they couldn't see their words didn't mean that they weren't there. And so the adjacent possible, I think, is a good way to understand our opportunities and constraints in this new immersive medium. And so before we get to some golden age of immersive reality design, we need to work through this paradigm shift, and that means that as a community, we need labor-intensive explorations and sufficient markets to test our ideas in. We can only think these new immersive reality native thoughts when we probe our adjacent possibilities to find new adjacent possibilities, and eventually we'll coalesce around some great patterns. So how do you expand your adjacent possible into a new job? There are 5 steps. First, understand your constraints. Second, learn some tools. Third, build anything. Fourth, luck. And 5, profit. In this talk, when I'm talking about AR and VR, I'm talking about these kinds of headsets, not necessarily mobile AR. So let's start by learning some constraints. VR and AR lets us do so many new things. This is something I've heard from a number of people, including myself, and sure, it's mostly true, but what are some of the things that won't change? If we look at the content of what we're designing, sure, spatial design is different from flat rectangle design. There are new principles, new ways to treat text, new ways to treat environments, new ways to lay things out, but all of the high-level principles remain the same. For instance, Jacob Nielsen's usability heuristics. The concept of error prevention is still highly relevant in spatial realities. We can look at Amber Case's principles of common technology. One principle, the right amount of technology is the minimum needed to solve the problem, is still necessary here. Dieter Rams's principles of good design makes a product understandable. Yep, still necessary. And we can look at John Maeda's laws of simplicity. One of his laws, organization makes a system of many appear fewer, is still necessary in immersive design. And beyond all of these high-level design principles, we're still making products, and so we still have to make shit that people care about. Things that people want, things that help people achieve their goals, and things that just overall make the world a better place. And so if you're already a good flat designer, then you have a good start in AR and VR. You know the high-level design principles, and you know how to craft products that people care about. And let's keep learning. So, as other speakers have emphasized, a huge differentiator in immersive realities is that they are spatial in a way that goes beyond all of our pocket rectangles. And that opens up a new set of design problems. Given that I only have 30 minutes, not a whole semester to lecture, I'll just point out a few different things that I've either dealt with or thought about, all of which I think are still innovation opportunities. So maybe one question, how do we find ways of using depth meaningfully? Maybe your typography or menu system uses distance to convey something to the user, like here, a hover state. Maybe we embrace the user's ability to move anywhere in the scene. Here in Alamet, a user can put their head inside of a ship that is there in the scene. And maybe applications should stop living in rectangles anyway. Many human tasks are already spatial. We've just optimized ourselves to think that flat is the way to go. So, for instance, here when I was writing my children's book, I used way more space than my little rectangle allowed. An additional question, how do we think in terms of layers or superpowers instead of single applications? So So if we think about a desktop, sometimes I have a single app that takes over the screen, and this is kind of similar to where we are with AR and VR now. I have one app that runs, and I can't really access my other content. And then a little bit now, but more so in the near future, we'll have a window metaphor too, where I can access multiple apps simultaneously and use them all together. And also soon, you may have superpowers as services that run in the background. So on my desktop, Image Optim compresses all of my sketch exports automatically. In AR, maybe that's that Duolingo helps me practice my Portuguese nouns by overlaying them over objects in my world while I'm still using all of my other applications. Our job as designers is to have the user, or to help the user have clear expectations around these different applications and services. An additional question maybe, how do we translate existing paradigms? How do we select something, especially if it's far away? Should I have something like a laser pointer? Or should I only let the user use direct manipulation? Or maybe should I lean on voice interactions, like for Samsung, that would be talking to Bixby. In spatial design, we don't have a flat rectangle to put a hamburger menu in the top left of, or a tab bar in the bottom of, and so you're going to have to start thinking about how menus can either live around you, or with you, or if you need them at all. And even something like a slider design can be very different based on your interaction model and the available user input. You may choose one of these for direct hand manipulation, and a different one for controller-based interaction. Materiality. So here I'm going to pause for about 10 seconds, and I want you to really take in the room around you. So what did you experience? The real world has a particular materiality. There's a background audio landscape. There's people moving a little bit, the HVAC system running, we can hear laptops humming along if you're close enough. Every action we take makes a noise. And looking around the room, you'll notice how everything has a particular texture. There's a particular way the light bounces off of different materials, and you know what to expect when you feel certain objects or surfaces. These same concepts are present in AR and VR because we're creating spaces and experiences that either play in a realistic world or at least an internally consistent one. So we can look at a VR game I really like called Luna. In it, you follow this little bird around as it connects with different animals. And here you'll notice that the game isn't quite realistic, but everything works well together and responds to user action. So just like in flat design, you might keep your font styles in a certain way. You'll need to start thinking about how to keep your materiality, one, just present and existent, but also, two, consistent. When we work with our black rectangles, it is always good to note the user's context, to understand when and where they'll use the app to better design how they'll use the app. And this problem is now exponentially harder. You can usually assume that your user is looking at your screen, but in VR and AR, the user could be looking anywhere, and depending on your interface, that could be good or bad. Perhaps your user starts your application facing in one direction, but then sits down and is facing a different direction. Maybe someone comes to the door while they're in a VR experience, or maybe your cat knocks something down. And if you're in AR and your cat has knocked something down, you don't want the UI to just be pasted to your face, because you still have to live in the world, and as designers, we don't want users to start hating their headsets. Our users are also going to be living in different spaces, so some are going to have meters and meters of room to walk around in, and others will have spaces that are more compact and limited. And the same user is going to move throughout different spaces throughout the day. You might also want to design for nice large surfaces on, perhaps in an AR context, but real spaces are considerably more messy. And so here you're going to have to think, do I want to force the user to clear off their space, or do I need to accept this as a constraint? And regarding tracking, depending on the system, a headset may require a lit room with enough variation in the textures around it to track, which is to say, nice large swaths of a particular color are not distinct enough. And headsets don't usually understand glass, mirrors, screen doors, and they don't track the cats beneath your feet. If you're relying on a particular input modality, you also need to recognize what your user is comfortable with. So if they happen to be on the bus, they probably want to be maybe a little more discreet. If they're in the office, maybe they're okay with hand motions or a controller, but they might only be comfortable with voice interactions at home or when they're alone. And you're going to need to decide how your application responds to all of these various contexts. Working in a spatial medium lends itself to 3D objects and interfaces, but there are a couple ways you could go wrong here. So you could have too few 3D elements, and your application could feel flat. This is especially the case if you look at things from the side. You don't really want your interface to disappear. You could also make your interface maybe too spatial. So this is a short project I did in grad school. I added depth to the text, so I thought it would be a little more interesting and not so flat, but that ended up actually decreasing the legibility of the text. You could also make your interface maybe too long. So like this rethinking of Facebook, I think it looks interesting, but I'm not really sure how it would live with my other apps, my existing space, and I'm not sure that the hierarchy is entirely clear. And then also, at this point, disclaimer, when I show work from other designers, I comment on them with the context of 3D product design, entirely recognize they have different goals and constraints. Hardware is expensive. And if you're getting into this industry, I really think that you need to buy some hardware or have extremely easy access to hardware. And it sucks, especially if you don't have the disposable income. But I think it's the best way to get a handle on what is possible and what's happening. You buy a headset and you try out the available experiences, and then you also use that headset to build prototypes too. The experience of AR and VR is so different from sketching and so different from flat prototyping that you really need to buy a device or borrow a device or just find somewhere to try a device. And here, Google Cardboard is the absolute bare minimum and how I personally got started. But I suggest getting a higher-end system if you can. My work is so much better for it. So now that I've talked at length about a few constraints, let's review an AR mockup for maybe some additional constraints we can learn from. I found this GIF on Dribble of an AR running concept. And I use it in part because I think it's a good example of what you might pass around inside your team. So yeah, I'll just let this play for a sec. Cool. So a few notes. Highlighting the field of view, I think is really, really good because right now, in this instance, our AR headsets are a little limited, and so it's good to imbue in the person who is observing this mockup what the actual experience might be like. And then also, I think here, blurring the background is good because if I actually am viewing a nearby object, that my eyes converge at this point and naturally blur out everything behind it. Though, for both points, the designer later removes both the field of view and the blurred backup, and so that wouldn't necessarily be my style. So here, she's also using eye tracking for selection, and I am not overly confident that eye tracking alone is a good selection method. At least I have not seen a great demo for it. Also, so in AR, your interfaces become transparent the amount they are black. And this is because we're using additive displays. We're turning on lights, turning on projectors, and shining them into your eyes. And you can't turn on a light that removes other light. And so your visual designs are going to have to change a little bit. But a good note, if you look at the lower Nike logo, there's a slight shadow around it. And this does work because it's rendered on top of another element. And even though the black is punching through all of the UI so that you would see the world behind it, your eye can still perceive this as a correct shadow. Yeah, and so I call them effective shadows. And also, because we're usually working in game engines, shadows can be costly to render, and so don't expect to get nice long drop shadows unless you have some engineering expertise. Also, the background UI blurring here is non-trivial and computationally expensive to recreate in both AR and VR. And so again, work with your engineers to really understand your constraints. Using a HUD concept, so a heads-up display, an interface that might float around my face, is usually not not that exciting. I think here, though, it makes a lot of sense, right? That if I'm running, I don't want to have my interface stuck at the starting line. And so, yeah, here, I think that's a good point. New example. The big AR platforms today have occlusion systems where virtual content gets clipped by the real world. And this is pretty cool because if you put something on your desk or have a whale floating in your house and you walk into another room, the walls hide your interfaces like they should. But hand occlusion and occluding other moving objects is still being worked on and being integrated into the various headsets, so we don't get that for free yet. And last thing in this section, immersive reality encompasses more than headsets. So immersive theater, projection mapping, audio-based art, interior design, architecture, literature, and even conferences like here are all ways to create immersive realities. So don't just get caught up in what the headsets are doing, look to other places for examples. Okay, so let's say we've our constraints, and so now we can move on to learning some tools, and for better or for worse, you're going to have to learn some new tools. But you have a few places to start. So there's a more traditional game industry route where you might use Unity or Unreal, possibly with a 3D art tool like Blender, Maya, or Cinema 4D. And these tools are going to make you well suited to get a job in VR and AR because most of the industry actually uses these tools today. The downside is that it's like opening Photoshop again for the first time, and you have to do it twice, once for the game engine and once for the 3D modeling tool. This I have found to be a very hard path, but a good one. Another option is to go a web VR route. So here you might use an HTML JavaScript framework to build your VR or possibly AR experience. And this is what I did because when I was learning, I had some front-end web development experience already, and these tools just fit my mental model. So here you can use A-Frame, React VR, some other tool that you're used to. And the third option to use is immersive creation tools. And these are really great because you're creating in the medium that your creation will live in. Other tools will make you work on a flat screen and you occasionally put a headset on, and that really slows down your iteration time. The downside of the native path is that your engineering counterparts are likely working in a game engine on the production side, and so you're still probably going to need to learn some of that anyway. Okay, learn some tools, great, it's time to build something. And this one I can't help you with too much, that you just have to do it. When I was learning it, it took a lot of time and effort. It helped to have projects at the time that I could use VR in. It also helped that while I was struggling along, I just remembered that I'm helping to build this amazing future, and so keep that in mind. But I can comment a little bit on the ideation process. So when you're ideating, designing, and prototyping, you're going to need to properly convey your ideas to others like your coworkers and your boss, but also to yourself. You'll need to find ways to work quickly and accurately. High-fidelity spatial prototypes are clearest because they can be experienced, but we don't always have the time, nor knowledge, nor tools, nor resources to build out a bunch of ideas rapidly, and I think that's okay. I am of the mindset that if you have a good handle on your constraints, point one, you can prototype with anything, and that means sketching, paper prototypes, pantomiming, Sketch, Framer, Premiere, Blender, A-Frame, Unity, Quill, Blocks, Tavoy, Torch, really whatever. The goal of ideation and prototyping is to get a handle on what makes a good product as quickly and robustly as possible. And so if Unity if building something in Unity is how you roll, then great. If you can solve your problem with 5 minutes of sketching, then you should do that instead. Choose the tool that lets you appropriately express yourself, and if working with others, choose the tool that will let them understand as clearly as possible. So in my day-to-day work, when faced with a problem, I usually start by sketching out multiple versions very quickly, forcing myself to iterate through different ideas, pushing past my own adjacent possible. And then, depending on what I need to convey, I figure out what's the quickest and most robust way I can show that idea. Sometimes the sketch is just enough. Other times I might make a mock-up in Sketch. Sometimes I make little 3D interfaces in Framer. Sometimes it's showing a Blender render, and there are many times I have to blend different tools. So maybe I draw something in Quill or Blocks, export it to an image, and mask it in Sketch. Now, I also want to emphasize that if you choose to express yourself in flat tools, you'll be working against the tool to do what you want. So in Sketch, I use a little plugin called Magic Mirror that helps me do nice perspective transforms, and I play with different blending modes to kind of get a better idea of how that might look in AR. In Framer, I made a little slider thing that lets me change the 3D rotation of my mockup. But all of this makes me think of a quote from Nietzsche, that our writing equipment takes part in the forming of our thoughts. He wrote this after transitioning from writing on paper to using a typewriter and realizing that his thoughts were becoming a little more succinct. The medium was molding the message. And so you do have to be wary of your constraints. If you're using perhaps a VR tool for an AR design, you may miss the context in which your interface will live. And if you're working in Sketch, it doesn't render images like you'll see them in AR. The tools can be a little misleading and guide you in the direction that they were meant to be used for. It is up to you to bend them to your will and your needs. Let me wrap up this list by describing how we just hired 2 designers onto our team. We looked for a few things which actually happened to line up nicely with this list. So first, do they have good ideas? Which is to ask, do they have an at least rudimentary understanding of the challenges and opportunities in VR and AR? We don't expect them to be experts, but we do expect them to be a little knowledgeable about the space, and the rest they can learn on the job. Second, have they actually learned some tools? Ones that help them make prototypes. Again, don't have to be experts, but they do have to be able to express their own ideas. Have they built something for AR or VR? And that could be anything, really. They could be a prototype, though more points if it was a product with user feedback. Then 4, the luck part. Do they actually complement the team? So are they the kind of person we could use now, but also for future products? The specific team I'm on is a little smaller, and so we just happen to not have the flexibility to bring on anyone too junior at this point. So they could be a good designer, but as luck has it, we just wouldn't be able to bring them in. And then 5, profit. Are they hired, or in this case, are you hired? And once you're in, you did it, and you can keep learning, and at some point, stand up on the stage and give a talk to help others get into the field. As I wrap up, I realize that it may be of interest to you how I specifically got to where I am. And so while I don't think you need to take my particular path, here's what I did. In an undergraduate philosophy course, I was reading this essay that was a response to a different essay, and the author was going on this tangent about how you could have a camera attached to each different eye. And the last line of that tangent was, it is possible, by the way, with this setup, to see all sides of an opaque cube at the same time. And I think this single sentence helps solidify my interest in VR, but also lay dormant for a sec. I worked on some other things, including a conference startup called What If, a children's book called The Book of What If, as well as some freelancing and agency UX work and front-end web development work. Unfortunately, my startup wasn't growing as much as I would have liked it to, and so looking at other places I could make a large, ethical, well-designed impact, I started thinking about this sentence again. And so when Cardboard came out, I bought one. Started thinking about that one character in Pan's Labyrinth, whose eyes were attached to its hands and it could articulate them individually. And so I bought some screens, installed them in the Cardboard headset, and attached each one to its own camera so that I could effectively take my eyes out of my head. Here, half of the system is working, and I got both cameras to work, but it only worked for about 30 seconds. But that was enough for me to continue to want to go down this path. So later I went to grad school at Carnegie Mellon, adapting some of my studies so I could think about AR and VR. Did a few projects. One over here on the right a little bit was looking at how feeling things, haptics, if I could feel things in VR, how that might change my moral decisions. And it happened to be featured in the Wall Street Journal, and so as a grad student that was pretty neat. I also did a self-designed internship called Humane Virtuality, and here I did 1 to 2 week long design sprints, just looking at very specific challenges in VR. All of that got me to an interview at a big tech company that was not Samsung. And I got to the last round of interviews, but they happened to pass, and I actually think because of point 4, luck, that my skill set did not complement the team like another's did. I also, at around the same time, got an internship offer from Samsung Research America, and this very, very much felt like a step backward in my career because I had already been working professionally for a few years. But I decided that I would rather be an intern doing exactly what I want to do than a full-time employee doing anything else. So got to Samsung, did enough good work, and they hired me full time. Yeah, and so for the last while now, about 2 years, I've been working on future-facing products at Samsung, and I think that's pretty neat. So, we are at the point in our technological evolution of the room-sized computers, the car phones, and the 90s web. But it gets better every day, and this tech, built correctly, will help humans think more thoughts, or think new thoughts, and be more capable. What the adjacent possible tells us is that at any moment, the world is capable of extraordinary change, but only certain changes can happen. So it's up to you to expand what is possible and bring a more just, verdant, capable, and pleasing future. Thank you.